Literal equations. Literal equations are equations with more than one variable in them. The most common place to see literal equations is in formulas such as these. In this lesson, we are practicing solving a literal equation for a specific variable. This means to isolate the chosen variable on one side of the equals sign. To solve for a specific variable, remember that you will be using all the tools you already know to solve equations, but you must remember to focus on isolating the one variable that has been chosen. In this case, the problem requires us to solve for x, so we want x to be alone at the end of our work. Since we are not used to solving an equation with more than one variable, we are going to use a method that will help us transfer knowledge we already have. We will create a pretend equation using random numbers to replace the letters that are not x. The purpose of this pretend equation is to help us picture what steps we need to take to solve the literal equation. In this case, I have chosen to replace y with 5 and z with 7. The numbers do not matter. I just want an equation that matches the literal equation, so I can decide what my first step will be. To solve the pretend equation, I need to multiply both sides by 5. To match this step, I ask myself, what letter did 5 replace? 5 replaced y. So I multiply both sides of the literal equation by y. The solution to the pretend equation, then, is 35, which I got by multiplying 7 and 5. To show this on the literal equation, I multiply z times y. My solution, then, is x equals z times y, or x equals y times z. Once the variable we're solving for is alone, we have found our solution. In example 2, we are solving for p. I write a pretend equation on the right, replacing the letters with random numbers. In this case, I'm going to replace r with 3, t with 5, and I with 7. These numbers are random. I just make sure that they are different from each other so I can keep track of which one replaced which letter. My first step on the pretend equation is to arrange it in a more familiar pattern. P times 3 times 5 can be rewritten as 15 times P. I'm now going to match this on the left. I enclose r times t in parentheses to represent that I combined 3 and 5 into one new number, 15. On the right, I can solve the equation by dividing by 15. This gives me my solution. Since 15 was replaced by the parentheses RT, I'm going to divide both sides on the left by RT. My solution, then, is P equals I divided by RT. Once again, the solution is when the letter that you are looking for is alone on one side of the equation. In example 3, we are solving for f. In my pretend equation, I replace the other letters with random numbers, E with 5, G with 7, and H with 10. My first step in the pretend equation is to subtract 7 from both sides of the equal sign, for 5f equals 3. To match this on the left, I subtract the letter that 7 represented. I subtract G from both sides of the equation, for EF equals H minus G. In the pretend equation, I was able to subtract 7 from 10 for 3, but here I do not know what h minus g will become, so I enclose h minus g in parentheses to represent the new number 3. The parentheses h minus g takes the place of the 3 on the right. To solve the pretend equation, divide both sides by 5. The letter 5 was represented by E on the left, so divide both sides of the equation on the left by E. The solution is f equals h minus g divided by E. Once f is alone, we have our solution. In example 4, we are solving for j. Replace the other letters with random numbers. K with 5, M with 7, x with 2, y with 3. Before we begin, let's arrange the terms to look more familiar. I will write 5j plus 7j equals 2 plus 3. To match this on the left, write kj plus mj equals x plus y. To begin solving the equation on the right, we need to combine like terms. To combine 5j plus 7j, we add 5 plus 7 for 12j. To match this on the left, we need to realize what we did. We added 5 plus 7, which are represented by k plus m, and close k plus m in parentheses for k plus m times j. To combine like terms for 2 plus 3, we get 5. To represent this on the left and close x plus y in parentheses. The final step on the pretend equation is to divide both sides by 12. 12 is represented by parentheses k plus m on the left. So to finish the problem on the left, divide both sides by parentheses k plus m. This gives us our solution, j equals x plus y divided by k plus m. Once again, the solution is when the variable we are solving for is alone. In example 5, we are solving for r. Replace the other letters with random numbers. N with 5, P with 7, and W with 10. The first step on the right is to add 7 to both sides of the equation. For r divided by 5 equals 17. To match this on the left, add p to both sides of the equation. For r divided by n equals quantity w plus p. On the right, the last step is to multiply both sides by 5, for r equals 85. To match this on the left, multiply both sides by n. For this solution to be correct, it is necessary to keep the parentheses to ensure a correct answer. N is multiplied by the quantity w plus p, not only one letter or the other. The solution can be written as w plus p times n, or as n times the quantity w plus p. Or you can distribute it for r equals nw plus np. Any of these answers are correct, but you cannot ignore the fact that you are multiplying n times the quantity w plus p. In example 6, we are solving for y. For reasons I will explain in a moment, I will leave one extra variable in our pretend equation on the right this time. I am leaving the x in the equation. I am replacing a with 3, b with 4, and c with 12. Begin by subtracting 3x from both sides of the equation on the right. For 4y equals negative 3x plus 12. To match this on the equation on the left, subtract ax from both sides of the equation. For by equals negative ax plus c. On the right side, the final step is to divide both sides by 4. Our solution is y equals negative 3x plus 12 divided by 4. On the left side, to match this, we divide both sides by b, for y equals negative ax plus c divided by b. These are both correct solutions as they stand. However, we can also rewrite the solution on the right as negative 3 divided by 4 times x plus 12 divided by 4. Or y equals negative 3/4 times x plus 3. Both of these are correct solutions. On the left, we can rewrite the solution as y equals negative a divided by b times x plus c divided by b. Both of these are correct solutions. The reason I have shown you this example is that very soon you will be learning to convert what is called the standard form of a linear equation, which looks like this at the top on the right, to the slope-intercept form of the linear equation, which looks like this one on the bottom on the right. For now, we are just using this as further practice in solving literal equations. Please refer often to these notes as you complete your homework. Thank you.